Hi, my name is Darshan. I'm from tutoringmafia.com. Today's video is going to be an interesting one because we're going to talk about some hacks that we can use for SAT using Desmos. And to do that, we are joined with SAT expert Dan, the tutor. So I welcome Dan, first off, for taking in time and joining on our channel. And Dan, if you can just quickly give a brief intro about yourself, that would be great.
hmm Thank you, Darshan, for having me. I am excited to share all my tips and tricks for the Desmos, which was, we did not have any of this online stuff. Definitely no Desmos when I took the SAT. It was, the graphing calculator was all we had, which is definitely helpful. But we're going to see with Desmos, we can do a lot of the stuff faster and better. So that's very cool.
Exactly. And in fact, Dan, obviously, I would like to hear your opinion as well, because in the tutoring sessions that I usually have with students, whenever I ask this question that how much do you know Desmos or do you use Desmos actually in SAT, they reply that okay, we know SAT, but then when I start talking about the tips and tricks that we're going to talk about today, they give me a light bulb expression and they say, "Oh, is that possible in Desmos?" And at that point, I feel like the usage of Desmos in SAT, especially, is undervalued probably right now, and they don't use it as often, which obviously can increase the accuracy and save some time. What are your thoughts on that?
Yeah, I mean, even when we were making this video, I had to literally learn some new tricks that I didn't even know were possible. So if you're not familiar with it, then you're going to be in for a surprise when there's some really cool things we can do. And also, probably the most important thing after watching this video, play around with it yourself. This is something that's free. You can do on your computer. If you're watching this video, you can almost certainly play around with Desmos, and it's just going to make you that much more confident, not just on the SAT, but I do this all the time when I'm working with my students, not for the SAT, just for different calculus or physics classes. It's helpful to have a graphing calculator right at your fingertips.
Exactly, I absolutely agree. So the way we are going to proceed is we each have five tricks, and I'm going to share my screen first, and we'll talk about the five tricks that I feel would be helpful, and likewise, but Darren's going to do the same thing. We are also going to share the specific link of the Desmos that is used in SAT. It is not the same as the regular Desmos because the options are slightly restricted. So we're going to share that in the channel description. Make sure to check that out. All right, so I'm going to share my screen and let's dive into it. All right, excellent. The first trick, we're going to start easy. The first trick is how to find the mean and median of ungrouped data. And by the way, almost all the questions that I am using appeared in the SAT, probably pen and paper version, but all these are relevant questions. So here we are given that there are seven quizzes and then the scores are given. These are J's score uh, for the first seven math quizzes, and they're asking that which of the following is it true about his scores, and they are talking about the comparison of mean, median, mode, and the range. So I just want to highlight that mean and median you can very easily find using a tool that is inbuilt in Desmos. For mode and range, I don't think so you even need any tool in the first place because these are pretty easy to figure out. We all know that mode is like the number that repeats for the maximum time. I'm talking about ungrouped data right now. I'm not talking about any bar graphs or anything. So I know that I think 87 is here and 87 is here. So that's the only number that is basically appearing twice. So I'm going to write my mode as 87. I'm just going to highlight that over here. And range, as we know, is the maximum minus minimum. If I'm not wrong, the minimum is 75 and the maximum is 98. So 98 minus 75, that will be 85, 95, I think 23. So I'm going to keep these things here. And now I'm going to share Desmos to see how we can find the median and the mean and compare both of them. So allow me a moment to switch my screen. Um, there you go. So in order to go for the mean or the median, you're going to go at the bottom left corner and you're going to click on this option. It will give you further options. So you're going to go in functions. You click on functions and you scroll down. And in the statistics, you're seeing an option of mean and median, right? So you click on mean, the mean will appear right there. And at the same time, I want to have the median as well here. So I'll do the same activity for the median. Now, guys, we know that at least for the median, you have to arrange the data set in increasing order, but for technology, you don't have to do that. You don't have to worry about that. So just type in the numbers the way they are looking, right? So my first number is 87, comma 75, comma 90, comma 83, 98, 87, and 91. And there you go. We have our nice and cozy mean. Well, not cozy, not nice, but yeah, we have a number. Okay, what I want to do now is I don't really want to type in all the numbers again. So I'm just gonna select all this, Control C shortcut for the copy, and go over here and paste it over here. So it just gives me the median as well. So I have the median as 87 now, and my mean is 87 point something. All right, so I'm going to come back to my board. All right. So what we concluded from Desmos is something which is right here, having a mean which is 87.28 or 29 probably. So I'm going to say the mean is 87.29, and I'm going to say that the median is 87. Right. The first question is mode greater than median? Median is 87, right? Nope. Mode and median are equal. So it is not greater. So D is absolutely wrong because option one is ruled out. Is the median greater than mean? Uh, no, I don't think so. The median is greater than mean because the median is 87 and the mean is 87.2. So obviously, median is not greater than mean. So that's out and that's out. The only option remaining is option B, which makes sense that the range is greater than 20. Absolutely, it is greater than 20. It is 23. So that's how you're gonna do the mean and median questions, especially for ungrouped data. It's gonna save time, especially like for median, I said it should be in increasing order. For technology, you don't have to do that. All right, excellent. Let's move on to the next question where we are given equation of a circle and they ask us to find the center or the radius. In this question, they're asking radius, but they can anytime ask you the center as well. So we're going to talk about both. All right. The thing that I want to highlight is here the equation of the circle is opened up, as in it is not in the form of x minus h whole square plus y minus k whole square equal to r square. I mean, had this was the question, I know for a fact that the center is h comma k and the radius is r. But in this case, well, no, I do not know. Unless if I want to do it manually, I need to convert that into perfect square, like X family separately and Y family separately. I don't want to do that. So I'm gonna go to Desmos now, and I'm gonna show you how to you can just do a quick solution for this. So I'm going to erase this. So just type in the equation as it is, right? So I'm going to type in X and, click on the hat symbol on my keyboard to raise it to a power. So that goes on the power square, likewise plus Y square plus 6X plus 5Y equal to negative 45 over 4. Okay, there you go. We have a circle. Now remember that whenever you will plot a circle in Desmos, it's going to highlight four very important attributes for you. One is x-intercept. Obviously, we don't have any x-intercept here, so it won't be highlighted. I'll show you in a minute where it is highlighted. Y-intercept, that is the next thing. And 2 points that are diametrically opposite. And here we do have that. Uh, if you hover on this point, see, it already highlighted 1 point, and you go diametrically opposite, and that you have as another point. Obviously, these are not the answers. We are looking for radius and center, but we click on it so that it stays with us. So these are with us. Now it's pretty easy, right? Because I know that its height is changing from negative zero point 0.5 to negative 4.5, which is a 4 unit travel, if you agree with me. So the 4 unit is not the radius, it's the diameter, and the half of that is the radius, correct? So the radius of this circle is 2 units. While what is the center? Of course, the center is the midpoint of this. Now, if you guys are not a big fan of again using manually, although we do have an option for, provision for midpoint, it's just average of x coordinates and the y coordinate. You can use Desmos for that as well. Although I'm not certain if this will save your time or not because you have to, look for a lot of things. I'm going to show you that, but you're going to decide whether it's helpful for you or not. But at the moment, if we do it with a mental math, I know that -3 and -3, that midpoint is just -3 because that's the same thing, right? So -3 is going to be the x coordinate of the center. And what is the average of the y coordinates? Just add it mentally. It's pretty easy. Negative zero point 0.5 and negative 4.5 will give you -5. And -5 divided by 2 is negative 2.5. So that's going to be my center, which is -3, comma negative 2.5. I'm going to show you a Desmos way as well, but okay, again, please decide by yourself. So, okay, there's a cool option here. If you guys are seeing at this point, you see this option, you can just click on this and it will automatically come in the left side. So you don't have to manually type it in. So I'm going to do that for both the points. I'm going to mark these points as probably A equal to, and I'm going to mark this guy as B equal to. Now, if you want to find the midpoint of this, click on again a blank row, go in this, go in the function, scroll down to geometry, which is right here, click on the midpoint option. So click on that and just type in A, comma B, and it will automatically plot that midpoint for you. But obviously you want to see the coordinates. So click on the label and there you go. It's -3, comma negative 2.5, which is what we got, with the mental math as well. So you can choose which one do you prefer in that. Okay, I think this is it for our second trick. Let me share my board again. All right, so I've written the answer 2 and -3, comma negative 2.5. All right, cool. The next thing that we have here is, okay, this is interesting. So how we can graph a function, I'll let you read the question first. There's y equal to some factor version given, and the graph is in the xy plane. It contains a point A, comma B. A is only between -1 and 1. Which of the following is not a possible value of B, which is just the y coordinate? So you have a function, but you want to plot in a restricted domain. What is the restricted domain? It's -1 to 1 in this case, right? So I'm going to show it to you how you can do that on Desmos using a restricted domain. So I'm going to share my screen. There you go. Um, all right. The first thing is you can either type in y equal to something as you see in the question, or fx equal to something. I mean, both for Desmos, accepts Desmos knows that fx notation is for a function. At the moment, I'm just doing y equal to x minus 1, x plus 1, and x plus 2. Obviously this is graphed in its regular natural domain, but I want to restrict it. So I'm going to place a curly brackets over here, and I'm going to put -1 less than equal to from my keyboard. I just typed in the angle brackets less than and then equal to, so it automatically turned into less than equal to. X is less than equal to 1, and there you go. This graph is now in a restricted domain. All you have to do is find out which of the following of y value out of the 4 options is not possible. And I can see one of the option D is 1. Clearly, it's not positive. It just cannot take any positive value, right? It's going all the way to -2.11. So -2 is allowed, -1 is allowed, 0 is allowed because there you go, it is 0, but any positive number is just not allowed, right? So our correct choice in this case is going to be option D, of course. So I'm going to mark option D in this case. All right. Okay. How to solve, this is our next trick, how to solve composite or nested functions. So you understand composite and nested functions, right? When a function is like intermingled on the inside the other function, right? So for example, gx is now a composition of f of x because in f of x, the x is replaced with 3x. Remember that this trick works only when you are trying to find a specific value, not like g of f of 3x, for example. Now, f of 3x is just a function. Desmos will just graph it for you. Desmos will not tell you the equation of that function, right? So only when you're trying to find the value of composite function at a specific point, that's where this trick is going to be helpful. So let's plug these things into the Desmos. So I'm gonna uh, all right, so I'm going to clear this up. And I have f of x is equal to, that's my first function, which is x squared minus 3x. Like I said, Desmos understands what f of x is. And then the next one is g of x, which is equal to f of 3x. So you see, I just type in the way it is looking in the question, nothing fancy. And all you have to do now is type in g of negative 10, which you want to find, and there you go. No manual work. Answer is 990, which is, of course, option D. So this is pretty cool. Won't take much time and pretty interesting, I think. It's going to save a lot of time. And correct answer is option D. Right, the last trick that we have is how to find the regression equation of basically any function. I have written linear, quadratic, and exponential because these are primarily tested in SAT. But honestly, even if you are doing some other course like calculus or pre-calculus, this trick can be used. I mean, the Desmos provided is allowed, so you can use it over there. But okay, if you read the question, in the xy plane, the graph of linear equation of the form y equal to mx plus b, which is linear, and the graph of exponential ab raised to x, both contain points 1, comma 3 and 2, comma 4. If the point r, comma s is on the graph of the linear equation and the point r, comma t, notice that x coordinate is same, r and r, is on the graph of the exponential function where r is between, as it, excuse me, the x coordinate is between 0 and 4, and s should be greater than 3. It's okay to be lost because this is a difficult question. They are saying that if the x coordinate is between 0 and 4, and if the y value that the linear function is returning, which is s, is greater than the y value that the exponential function is returning, which is t, then which of the following is actually true, as in with respect to the x values? Where should the x values be so that the y value that is returned by the linear function should be greater than the y value that is returned by the exponential function? Honestly, if you do this manually, it's going to be a nightmare. And this was considered to be a very challenging question. I don't remember the year, but this came in SAT. So I'm going to show you how to use regression techniques to answer this question. We're going to go in Desmos. And like I said, the process remains same. Doesn't matter whether that's a linear or exponential or whatever kind of regression that is. First things first, go on the top left, click on this plus option, and you click on that table. So you have a nice and cozy table here. Here you plug in the points that are on that function. So the first point is 1, comma 3, and the other point is 2, comma 4. There you go. Now you decide what regression you need. For example, I need the first regression as mx plus b, right? So I'm going to type in y1. Now this is the thing, y1, not y. If you type in y, only y, it's going to give an error. Because you see carefully here, these are x1 and y1. So the regression is also in terms of y1 and x1. So you type in y1, you don't place an equal to sign, you place a squiggle symbol, and you type in just the way the question says. It's mx plus b, so I will type in mx1 plus b. All right, you have an equation here. Equation as well as the line. But I also want it's exponential regression, right? So I'm going to again type in y1, squiggle, ab raised to x1. And there you go. I have my exponential regression. Both are interacting somewhere. Okay. Now, if you see, I already said that they are talking about a restricted domain between 0 and 4. So honestly, I get a little confused when I see the entire. So I want to restrict the domain. I'm going to place a curly bracket here. Sorry, curly bracket here. 0 less than x1, because that's a new domain. x1 is less than 4. There you go. I'm going to copy this, Control C, Control V. There you go. Both are restricted now. Now I want to find that in which x interval is y of the linear greater than the y of the exponent. In other words, the linear should be above the exponent. Obviously, it's a little difficult to see right now, but if you zoom in, you see that between this point and this point, don't you think that the violet line, which is obviously over here, that's a straight line, is above the black one, that is the exponent. If it's difficult to see the colors, I'll just change it over here. Yeah, maybe this is better. So you can see the violet one is above the blue one. Blue one is the exponential, and that happens between 1, x equal to 1, and x equal to 2. So that's our answer in this case, which is between 1 and 2, which is option B. And that's all what I had for my 5 tricks. I hope it made sense. And I'd like to request Dan now to, well, surprise us with more tricks.
Yes, now it's my turn. So basically, what we saw with a lot of Darshan is a lot of the different, I'm going to say, non-graphing tricks. Obviously there was some graphs involved, but there was also some non-graph things involved, which, first of all, you might not even know was a thing. You might not even have known that median and mean and regression equations, you probably don't even know what regression equations are, if I'm being perfectly honest. But, there's a lot of potential out there. Now, with my 5 tricks, it's kind of funny. I go last, but I feel like I have the 5 easier tricks. Darshan, you definitely, in my opinion, had the 5 harder tricks. So thank you for making my job easier.
I think that even the easier tricks gonna go a long way because it's all about saving the time, like I said earlier. And whether it's easy, whether it's difficult, I mean, all the tricks are gonna be equally helpful.
Definitely. And by the way, as I'm, going through this, if you have anything you want to jump in on, just let me know, and because it's all about the people. Okay, so two differences you'll notice between me and Darshan. Number one, he had his problems all nicely laid out. I have a blank sheet. Second, he does the black screen. I do the unpopular white screen. And, you can make fun of me for that, but that's what I like. So the first thing I'm going to tell you is, I guess, problem number 6. You can use Desmos to show how to find intersection points. These are where the graph intersects. Now, one more thing that's super important to know. For all of the points that me and Darshan are showing today, all 10 of them, these are technically things you can do without Desmos. We technically don't need Desmos. A lot of times a graphing calculator will do it, but even so, for all these problems, you don't actually need it. Let me give an example. So if I want to find how many intersection points, and I have the functions y equals x squared plus 2x and y equals x minus 1, technically I don't need Desmos, I don't need a graphing calculator. I can solve this easily by setting the functions equal to each other like this, and then I have to subtract x from both sides and add 1 to both sides, giving me x squared plus x plus 1 equals 0. And from here, I would try and factor this. This doesn't factor, so then I have to do my favorite thing in the world. That's right, quadratic formula. And this is where I'm going to make my point. Even though you don't need Desmos, Desmos can save you a lot of time, especially if you don't like things like quadratic formula. As a matter of fact, I don't even think you necessarily need quadratic formula because Desmos exists, or even before your graphing calculator would help us. So now let's show how to do it in Desmos, the same question. So one thing that's fun to know, do I need to write y equals for this? Nope, I technically don't. I can just write x squared plus 2x. Although if you want to write y equals, it doesn't matter. And then for the second function, it was x minus 1. And if you want to tell how many intersection points there are, it's literally just looking at how many points there are that intersect. And in this case, it's 0. We can clearly see the red and the blue lines don't touch each other. Now, if hypothetically I make it, let's try and choose a number like maybe minus 0.6, minus 0.3. Yes, okay. So look at this. This one, much closer, isn't it? But I'm not sure exactly if it touches. Here's how I know it doesn't touch. 2 reasons. Number 1, if they did intersect, there would be a little dot like there is one right here or right here. We would have an intersection point as shown by the gray dots here. But since there's no gray dots, I know it doesn't intersect, even though it's close. And the second way I can prove it, I can zoom in really, really, really close just by scrolling in and out with my mouse. And once you zoom in, you see it doesn't actually intersect. Okay, so that's the first point I want to make. The answer for this one was 0, 0 intersection points. And again, you don't need Desmos, but that sure saved us a lot of time than this setting the functions equal to each other and doing quadratic formula. So that's tip number 6. Now tip number 7. You can also use Desmos similarly to finding how many intersection points. You can use it to find the number of solutions in our equation, which, by the way, the SAT loves asking this question. It doesn't always ask you what are the solutions. A lot of times the question is how many solutions do we have? 0, 1, 2, infinitely many, a lot of different options here. So as an example, let's say I have y equals 3 times the quantity x minus 1 squared minus 3. The first thing you'll notice is that this is written in vertex form, which vertex form is nice when I want the vertex. In this case, it's obviously 1, negative 3 for the vertex. But that's not the question. The question doesn't ask where's the vertex. The question asks how many solutions. If I were to solve this the normal way, the first thing I would have to do is I'd have to square the x minus 1 by foiling x minus 1, which I'm not going to do, but then I'd have to distribute the 3, and then I'd have to subtract 3. I'd have to simplify as much as possible. And then after I do all of that, and I get something, it's not going to be this, but let's just say it's 3x squared plus 2x minus 9 or something. I then have to set this equal to 0 and do this factoring all over again. It's a nightmare. So again, how can we make this shorter in Desmos? We can just, again, type in, I'll do y equals this time just to show it doesn't matter, 3 parenthesis x minus 1 squared minus 3. And remember, the number of solutions, that's how many times it crosses the x-axis. And here we see there are 2 points, 0, 0, and 2, 0. Of course, the question didn't ask what are the solutions, which would be x equals 0 and x equals 2. The question asked how many, and the answer to that question is 2 solutions. So 2 solutions for that one. Okay. Now, going down the line, we just talked about if there's one equation, but what if there's 2 equations? In other words, a system of equations. Well, we can use Desmos to solve system of equations as well. And if you remember before, system of equations usually has 2 methods of solving, right? We have elimination method and substitution method. And again, you can use elimination or substitution method. But let's say I have this system of equations, 2x plus 4y equals 0, and x minus 5y equals 13. For this one, I would probably use elimination method. I would multiply the bottom one by negative 2, cancels out the x, but, you know, this takes a while. Again, when I can very easily just go to Desmos, type in the first equation, 2x plus 4y equals 0, and now actually you see that this is a linear line. In other words, Desmos is a very powerful tool. It doesn't even need to be y equals. Like again, when I was taking the SAT on a graphing calculator, before I did any of this, I would have had to solve the function in terms of y equals. But with Desmos, it does it automatically for us, which is very nice. And then the second equation is x minus 5y equals 13. And again, it highlights the point where they intersect. This one was a weird decimal. Clearly, I did not do my numbers ahead of time. But if this were just like a round number, like for instance 3 comma negative 1, then that would be the solution. X is always the first number, y is always the second number. And don't expect to see crazy decimals, okay? You should be expecting to see fractions. Oh, I'm sorry. I meant whole numbers. But I do have a question for Darshan. If this were, for instance, like let's say 3.2 for x and 2.1 for y, let's say. Darshan, do you know an easy way to convert these decimals to fractions on Desmos, or no?
Indeed, indeed. So if on the next line you will just type in 3.2, you click on that left side, you see that circle,
Oh,
that over
yeah.
that, click on that. So it will give you a fraction actually.
Okay, that's there we go. There's an 11th tip for you. So, yeah, that's very helpful. And okay, back to the next question. That was number 8, system of equations. Number 9, this is, in my opinion, one of the hardest types of questions on the SAT. How to find the missing coefficient. And again, this is one of those questions you're guaranteed to see on the SAT. They love asking this question. It's going to look something like this. I have the function f of x equals 2x squared plus 4x plus c. And the question is, what is the value of c so that I get no solutions? And the question might look something like this, where they have answer choices A, -2, B, 0, C, +2, and D, +5. And most of the students look at this and they really just don't even know where to start with this. But now with Desmos, here's what we can do. First, there's a couple ways you can do this, so I'll show you the way I would probably recommend doing it because it's easier. 2x squared plus 4x, and instead of writing plus c, just one at a time we're going to put the different solutions in. Like for instance, here's c equals -2, which was answer choice A. We see here that this has two solutions, here and here, so that can't be right. So then you kind of just go down the list. Next is plus 0, where answer choice B was 0. Again, there's two solutions. Answer choice C was plus 2. Now, here's the thing I mentioned earlier. If it's close that we don't know if it actually touches or not, this touches. How do I know? The gray dot showed up and it tells me what the solution is. So even if I zoom in, it's going to be touching. Again, confirming what I was just saying. And then finally, the last one is 5, and we see 5, that doesn't touch the x-axis, so answer choice D is the correct answer. Now, like I mentioned, there is two ways of doing this. Let me show you the second way. The second way is, instead of typing in the answer choices, you can also literally write C, and you see what just appeared here, add slider, C. This is definitely one of those things you have to play with to get used to it, but see how it says here C equals 1? If I move the slider, I'm changing it to the different values, and it's literally changing the graph for me. And one thing we notice is that as soon as we get past 2, any value higher than 2, we're not going to get any more solutions. In other words, any value of C greater than 2 would have been no solution. Any value 2 or less would have been at least one solution. So again, play around with that because that's a very interesting one. And again, they love asking questions like this, and if you don't know how to solve it, this is brutal because it's a really hard question. And then the 10th and final tip I have today is how to solve systems of inequalities. And remember, systems of inequalities are very similar to system of equations. The biggest difference is we're looking at the greater than and less than signs. So for instance, if I want to, let's say, find the solution between y is greater than or equal to 3x minus 4 and 2x plus y is less than 7, and then maybe the different answer choices give 4 different coordinate points. Let's first graph it to see what this looks like. The first one, y is greater than or equal to 3x minus 4, and immediately we see we get this shaded region here. If you don't like the color, by the way, which sometimes, black shows up or something that's hard to read, you can change the color by going to the gear, click the color, click any color you want. By the way, you can play around with this too. This is opacity, which just means how see-through it is. So for instance, if I put 0.5, it's going to make the line a little more faint. Okay, the max value I think is 1. And then you can have line width. Line width standard is 2.5 by default, but you can make it, for instance, 10, and now the line is really thick if you want. And again, you have the fill here. This is opacity. You can make it 0.8 to make it even darker. You can make it 0.1 to make it so light you can't even see it anymore. But again, the default is whatever. So anyways, I'm going to set it back to the default. That's the different things you can play around with. That's the first equation. For the second equation, 2x plus y less than 7. And there, I see where the graphs intersect, but the question's probably not going to ask where the graphs intersect, which in this case 2.2 and 2.6. What's more likely to happen is the question's going to give you 4 coordinate points, which I'll just make up right now. Let's say A, answer choice A is, let's say 4 comma 2. Let's say answer choice B is 6 comma 0. And you can clearly see as I'm typing out these points, they show up here. Okay, these guys are not in the intersection point. And most importantly, let's say answer choice C is 2 0. Well, that one shows up in one of the shaded portions. But remember, in order to be a solution to a system of equation, you need to show up in both this really dark shaded region, or else it's not really a solution. So A, B, and C are all wrong in this example. And let's say D, which has to be right because it's the only one left. Let's say D is 0 comma negative 4. And this one, if you look, is on the line. Is that okay? The answer is yes, because it's the solid line. If we were on the dashed line, which I think as an example would be like answer choice E, which would be 0 comma 7. Okay, if that point's not good because it's on a dotted line and we need it to be on a solid line in order for it to be inside the region. So in this case, answer choice D would be correct. And that's basically all of the tips I have for these 5. And Darshan, you can take it away from here.
Yeah, no, it was perfect, especially the gear thing that you showed around. Like, although I know I'm not sure how much helpful that would be, but that was pretty interesting that you can actually change the faintness, the thickness, and you can change the colors as well. So honestly, I didn't know that. So that's something that I learned from these tricks. So yeah, it was amazing. I mean, so for anyone who is watching this, if you like this video and would like to see more of anything, probably as a joint collaboration of me and Dan, just feel free to let us know in the comment section, and we'll do our best to make a video on that. So yeah, thank you, Dan, once again for taking in the time, and I hope that we are gonna make a new video very soon.
Yep, absolutely. Absolutely.
All right, see you then. Bye.